All right, mass to mass stoichiometry, the homework from section 2 of unit 7. I'm going to go over this. So that means it was due um, Wednesday the 10th by midnight. So if you had not done this version of it, it will close out because I'm going over the answers and posting them. But there is a version 2. Um, so you can do that to gain credit. So let's go over these for those of y'all that were having problems. Now this looks a little different from the sheet you guys saw because I've made it bigger, so when I have space to write. But anyway, you are looking for the molar mass, and it'd be really nice if this would let me write on the screen. Here we go. Looking for the molar mass of each one of these compounds. So you're looking up cobalt and you're looking up fluorine in the periodic table, and you see that cobalt has an atomic mass of 59 and fluorine has an atomic mass of 19, and there's 3 of those. Okay, so that's going to give you a total of 57 for the fluorines, and when you add them all up together, you should have gotten 116 grams, and again, this is per mole. And then you have to figure out how many moles you have, or how much is a fraction of a mole, um, when you are just working with 3 grams of the substance. So remember the way you do this, you start with, the mass that you have, and in this case, it's 3 grams. Okay, and then we're trying to figure out how many moles are in 3 grams. So 1 mole of our compound, we said, was equal to 116 grams. Put the grams down here so they cancel out, and then you just do the math, and you should have ended up with 0.0, and it rounds to 26 moles. You could have carried it out several decimal places, but 0.026. That's what I said. This one's a fraction of a mole because once you see how much the compound weighs, it's 116 grams, and you're only working with a really tiny little bit of it, then you should have realized that you're going to get a small number here. All right, for this one, let's take a look at our periodic table. This compound, or this element, has an atomic mass of 119, and then our iodine is 127, and you have 4 of those. Okay, multiply that by 4, and the iodine is going to contribute 508. So this is a pretty heavy compound. So you add these together, 119, 508, and you're going to get 627 grams per mole. And you are, again, I didn't mean to make all these so tiny, but I guess I did. So you're going to have fractions of a mole for each one of these. So you only have 5.5 grams. So start with the grams you're given, 5.5 grams over 1 times. And we said 1 mole of this compound weighs 627 grams. That way grams cancel out. You do the math. And this time you should have ended up with like 0.00877, but you can just round to 0.009 moles will be fine. I mean, if you carried it out 0.00877, that's okay. That wouldn't have been a problem. All right, and our last one here, let's see, we've got potassium. Look on the periodic table, it's got an atomic mass of 39, but there's 2 of them, so that's times 2. So that's going to contribute 78 grams to this mass. And you got sulfur, and that's a 32 on the periodic table. And you have oxygen, which is 16, but you have 4 of those, so times 4, which gives you 64. So add up 78, 32, 64. When you add all that together, you get 174 grams, again, per mole for that compound. And again, we're dealing with a very tiny little fraction, so you know it's going to be under 1 mole. But again, start with what you're given. We're given 4.5 grams times, and we said 1 mole is equal to 174 grams. Cancel out the grams. It'll leave you with moles, and you should have, this one, I didn't plan this out either, but you're going to end up with the same number you did up top. Again, poor planning, Miss Taylor. But yeah, those are the same. I said I didn't mean to do that. but that should have been your answers for this top part. Okay, I'm going to clear this out so I can scroll on down. And all right, I don't understand why Google Drive can't fix my little, these should be arrows and not question marks. I know they do it all the time. And like for math, certain math things, they just don't translate well. But guys, that should be an arrow. Y'all know that. Okay. So when you do these problems, remember I told you there's 3 steps. And if you look at my stoichiometry tips sheet that I put in Unit 7, you'll see one of the first things I want you to do is either circle, highlight, or underline what you're working with. All right, let me get me out of the way. So we're working with hydrogen and nitrogen. Okay, so step 1, take the grams given, and in this case, they're giving us how many grams of nitrogen here, which is 50. So we've got to convert that to moles. So 50 grams of nitrogen, remember it's N2, times 1 mole of nitrogen, or N2. If you look up nitrogen on the periodic table, it's a 14, and we have 2 of them. So 14 times 2 is 28 grams in 1 mole for N2. All right, and then you can do the math there, and you're going to see that we have 1.79 moles of nitrogen are found in this 50 grams. Okay, so that's the number of moles that we have. Step 2 is that mole to mole ratio. So again, this is where you got to look and see what you're working with. We're working with hydrogen, and we're working with nitrogen. All right, let's look at our ratios. When we're looking in this formula up here, there are 3 hydrogens to every 1 nitrogen. But we know that we don't just have 1 nitrogen. We have 1.79 moles of nitrogen, and we're trying to figure out hydrogen. All right, so our first ratio, 3 over 1, and x over 1.79. Okay, 1 times x is x. 3 times 1.79 is 5.36. So that tells you how many moles of H2 that you have when you have 1.79 moles of nitrogen. And it's asking you for grams. So this is why we got to convert that back to grams. Step 3. All right, we know we have 5.36 moles of H2 over 1. And H is 1 on the periodic table. And since you have 2 of them, 2 times 1 is 2. So that's 2 grams in 1 mole of H2. See how we put the moles on the bottom this time so that we cancel out because we're trying to get grams in this end step. So 2 times 5.36 is going to give you 10.7 grams of H2, and that is your answer. I think some people got a slightly different decimal, like 10.5 or whatever. It just depends on, you know, how well you're rounding those atomic masses. But if you got in the ballpark of 10.7, 10.6, 10.5, you'll be fine. Okay, now on to part B. Now we're looking at the grams of ammonia produced in this reaction. Well, let's go back up because we can't see everything in this picture. Actually, I'll just rewrite the equation. That way you can see it. All right, so our equation was N2 plus 3 moles of H2 equals 2 moles of NH3. Okay, so now they want to know how many grams of ammonia. Now, this was based on what you just calculated. So you could either use, we said that we had 5.36 moles of H2 for that one. Or in the problem above, it said that we had 50 grams of nitrogen, which we calculated out to be 1.7 moles of N2. Now, you can use either one of those. You're going to pick. I guess since we had to calculate the hydrogen, and that was the answer to the last one, we did it in grams, but at this point, we need to figure the mole ratio. So we've kind of already eliminated step one. So we just won't even worry about this part. So when you're trying to ask about a product, in this case, they're asking about the ammonia, remember, you've got two reactants. So you can just pick whichever one you want to be the other ratio, or the other number in the ratio. Okay, but again, since we already figured out in part A that we have 5.36 moles of hydrogen, that's the one we're going to roll with. All right, so let's look at our mole ratio. We are using hydrogen, and we're trying to figure out our ammonia amount. All right, so in our equation up here, it's a 3:2 ratio. But we know we have this many moles that we're working with for hydrogen, 5.36. And we're trying to figure out how many moles of ammonia that we have. All right, so let's set it up. Our first fraction will be 3/2. And our second fraction is 5.36 over x. And then cross multiply. 3x equal to 10.72. And then solve for x. You plug that into your calculator. You should end up with 3.57 moles of ammonia. Now, that's not the answer because we've got to convert it to grams. So, last step, convert to grams. All right, well, first we got to get our molar mass of ammonia, which that's pretty easy. Nitrogen is 14 on the periodic table. Hydrogen is 1, so 1 times 3 is 3. So that's 17 grams per mole of NH3. All right, so we know we have 3.57 moles of NH3 over 1. And since we're trying to eliminate the unit of moles, we put moles down here. So 1 mole of NH3, and see now, that'll cancel out, is equal to 17 grams. Okay, do your math. And I'm trying to find my answer on my sheet. What did I do with it? Step 2, there it is. 60, I got about 60.75 grams of NH3. So that's a true answer right there because they wanted it in grams. So on your sheet, that was the answer you should have provided. Okay. Moving on to the next. Again, I don't understand why these things don't transfer over the arrows the way they're supposed to when we download to Google Docs. So that's supposed to be an arrow. All right. So again, as I said in our tip sheet, underline what you're working with. We got lithium hydroxide, which is here. Lithium bromide, which is here. All right, we've got 10 grams of lithium hydroxide. So step 1, we got to convert that to moles. All right, 10 grams of LiOH over 1. We got to figure out the molar mass of lithium hydroxide. So molar mass of LiOH. You look up lithium on the periodic table. It's like rounded to 7. I think it's 6.9. You can leave it 6.9 if you want, but it's so close we can round it. We have 1 oxygen, so that's 16. And we have 1 hydrogen, which is 1. So that adds up to 24 grams per mole. All right, so 24 grams per mole. Cancel out your grams, and that's going to leave you with moles. So for this one, we're going to be working, when you do your math, you'll see that you have 0.42 moles of lithium hydroxide found in those 10 grams. Okay, so step 2, now that we have our moles for that, we're going to look at our mole to mole ratio. So lithium hydroxide to lithium bromide, and the equation, there's, it's a 1-to-1 ratio. This one's easy. Because remember, anytime you have a 1-to-1 ratio, it's going to be the same for both. So since we have 0.42 moles for lithium hydroxide, we're also going to have 0.42 moles for lithium bromide. So that was easy. And then step 3, you just got to convert the 0.42 moles lithium bromide into grams. Okay, so we need our molar mass of that one. Molar mass of lithium bromide. We already said lithium has 7. If you look up bromine on the periodic table, just round it to 80. So 87 grams per mole for lithium bromide. Again, put moles on the bottom of this fraction so that we can cancel them out because we want to be left with grams. Okay, so when you do the math for that, you should end up with something like 36.25 grams of lithium bromide. So that's your answer for number 5. Number 6. All right, again, always start off. I know some of y'all are not doing this, and it does help if you do it, so keep yourself straight. Sodium fluoride, and magnesium fluoride. And again, that's supposed to be an arrow. And so we're starting with sodium fluoride. So step 1, if you start with 5.5 grams of sodium fluoride, how many grams of magnesium fluoride will be produced? All right, well, so we got to convert this to moles. 1 mole, we got to do our molar mass. So let's go over here. We have a little space and do our molar mass of sodium fluoride. Sodium is like 23, and then fluorine is 19. Add those together, you get 42 grams per mole. All right, so 42 grams of NaF in 1 mole. Okay, and we put the grams on the bottom here because we're trying to isolate the number of moles. So when you do your math, you should come up with 0.13 moles of NaF. Now we got to do our molar ratios. All right, so we know we're dealing with sodium fluoride, and we are also dealing with magnesium fluoride. All right, in the equation, you'll see that there's 2 sodium fluorides to every 1 magnesium fluoride. And we know that we have 0.13 moles that we're actually working with. So we're trying to figure out how much magnesium fluoride we would get if we only had 0.13 moles. So set up your problem, or your cross multiplying problem, 2 over 1, and then 0.13 over x, and solve for x. That should be a equal sign, sorry. 2x is equal to 0.13. Solve for x. And you're going to get a small number, 0.065 moles of our magnesium fluoride. Okay, so we know how many moles we have, but we got to convert it to grams. So that's our last step. We got to do our molar mass of magnesium fluoride. If you look on the periodic table, let's see, I wrote it somewhere. I don't have my periodic table in front of me. Where did I write? Maybe I have to get my periodic table. Hold on, guys. Magnesium, 24. Right. So magnesium is 24 and fluorine is 19 times 2. And I know I wrote this down. Oh, there it is. Yeah, 24, 19, 30. I was trying to find it on my sheet. 38. And then when you add all that together, you get 62 grams per mole for magnesium fluoride. All right, so we know we have 0 right here, 0.065 moles of magnesium fluoride. And 1 mole of magnesium fluoride is equal to, what did we just say? 62. The moles cancel. And our final answer, you should get 0.065 times 62 is going to give you 4.03 grams of magnesium fluoride. And that is our answer, our final answer. That's a 2, by the way. Okay, 4.03 grams of magnesium fluoride. Again, it's the same steps over and over and over again. Nothing's really changing with how we're doing these problems. Okay, next one. Okay, so read your question. How many grams of lithium nitrate, there's your lithium nitrate, will be needed to make 250 grams of lithium sulfate? There's your lithium sulfate. So those are the 2 things that you have, assuming you have adequate amounts of the lead sulfate. So we don't have to worry about, running out of the other compound that we're using. All right, so step 1. We have to convert our 250 grams of our lithium sulfate into moles so we can do our mole to mole ratio. So we got to figure out how many grams in 1 mole. So let's do our molar mass of Li2SO4. Lithium, we said, had an atomic number of 7, and we have 2 of those, so that's going to give 14 grams. We have sulfur, which has atomic mass of 32. And we have oxygen, which has an atomic mass of 16, and we have 4 of those. So 16 times 4 is 64. And when you add the 14, the 32, and the 64 up, you get 110 grams per mole. Okay, so 110 grams. That allows you to cancel out your grams, leaves the moles. And when you do this, you're going to end up with 2.27 moles of our lithium sulfate that we need to use in our mole to mole ratio. All right. So look what we're working with. We're working with lithium nitrate and the lithium sulfate. Okay, so we got to look at our mole ratios. In the equation, there are 4 lithium nitrates to every 2 lithium sulfate. But we know we have a little over the 2.27 moles of lithium sulfate, and we're trying to figure out how much lithium nitrate we're going to get with that amount. So set up your cross multiplying problems. 4 over 2 is equal to x over 2.27, and solve for x. 2x is equal to 9.09. Again, that's hopefully y'all know how to cross multiply. 4 times 2.27, that's where I got the 9.09, and then 2 times x. All right, and then solve for x. And in this case, x is equal to 4.55 moles of LiNO3. So we know how much, but we need it in grams. So that's our last step. We are going to convert our 4.55 moles, 4.55 moles of our lithium nitrate into grams. So we got to figure out how many grams are in 1 mole. So lithium equal to 7. We have a nitrogen in there that's equal to 14 on the periodic table, and we have 3 oxygens. Oxygen is 16, but we have 3. So that's going to give us 48 for the oxygen. If you add all that together, it's 69 grams per mole. Okay, so 69 grams. Again, this is how many are in lithium nitrate, so we can cancel out our moles. And now if you just plug that in the calculator, it's 4.55 times 69. 3.13, oops. No, not 3 point, it's 300. 313.6 grams of lithium nitrate is produced from 10 or 250 grams of lithium sulfate. So that's your answer. All right, guys. Hopefully this video helps. Again, if you haven't done this homework yet, then you need to do version 2 if you want credit. It is in the modules section in Canvas. Again, if you have questions, please let me know. Just email me or ask in class. Have a good day.